Slow down. Today we're gonna do two things. First, add some colors for all the tiles that are discovered and analyzed, and then we're gonna slow down the pathfinding. But actually, why would we want to slow it down? Well, there's actually two reasons. The first one is just because it's going to look nice when we are displaying the pathfinding algorithm in progress. And the second one is to give us the possibility to split the calculation of the pathfinding over multiple frames. That way, even if the player tries to calculate a super long path that will take multiple frames to calculate, maybe 30 frames, 40 frames, like more than a second to calculate, it won't freeze the game during the process and it will simply give us the path at the end once everything is calculated. That way the game will remain smooth, and that's pretty important. So let's get to it. Okay, so we're gonna start with the colors. So I'm gonna go in the Blueprints Core Grid Utilities and open eTileState to add the two new states we're gonna need for the colors, so new and new, which I named is discovered for the discovered tiles and is analyzed for the analyzed tiles. We can now save and close that enum. And the next step is to go in BP Grid Mesh Inst to set the colors. So let's open that one. And here I'm going to add the two new states in the make array, so is discovered and is analyzed. The order doesn't really matter because one tile cannot be discovered and analyzed at the same time because we are removing them from the discovered when we are analyzing them. So both can be in any order, it doesn't really matter. And finally we have to change the color, so I'm going to change my discovered and analyzed color right here. And I chose a shade of pink for the discovered and a darker pink for the analyzed. And now we can compile and close this blueprint. Perfect, now we just need to go add the states to the tiles, and I'm actually thinking to add it inside the same blueprint as we are using for the text on the tiles. I'm just going to rename it so it makes more sense. So I renamed it BP Debug Text and Colors on Tiles, and then I'm just going to fix up the redirectors just to make sure that everything is updated, like that. Perfect. We can now open the blueprint. And in here, the first step is to add two new booleans for the discovered and the analyzed. I named them ShowDiscoveredTiles and ShowAnalyzedTiles. And then we're gonna need a few new functions. The same way we did when we are updating the text on the tiles, we're gonna do the same exact logic, but for the states this time. So let's create three new functions. And we're gonna start with the first one, so I renamed it UpdateStateOnTile. I'm passing it an index as input, which is an int point like the other ones. Then we're adding a sequence and two branches because we are going to process first the discovered tile and then we are going to process the analyzed tiles. Then for the discovered branch, well, we want to know if the index is part of the discovered list, so we connect that inside another branch, and we do the same thing for the analyzed. So in the analyzed branch, we are checking if the index is contained inside the analyzed tile indexes list. And finally, we add or remove the state depending if they are in the list or not. So if they are in the discovered list right here, we are adding is discovered. If they are not in the list, we are removing it. And same thing for the analyzed. So we are adding is analyzed or we are removing is analyzed if they are not part of that list. And one last thing to do is if we don't want to show the discovered tile, we're just gonna make sure to remove the state if it was there, and same thing for the analyzed. So if we don't want to show the analyzed, if it has a state, we are going to remove it. Perfect, we're now done with this function. We can go to the next one, which is the new function one right here. I renamed it UpdateStateOnAllTiles and it doesn't need any input or output. And then the first step is to check if we want to show at least one of the discovered tiles or the analyzed tiles, because if we don't want to show any of them, well, we're simply going to clear them all. So we are clearing the discovered state here and the analyzed state here. So if we don't want to show any of those, we're gonna clear them, otherwise we're gonna show them. And since this is the update of all the tiles, we're simply going to take all the indexes in the grid tiles, and then we're gonna loop through them all and update the states on the tile. And we can now go to the last function, so that one right here. And this is going to be the function that lets us set the two booleans, the same way we did for the text right there. So we are setting the ShowDiscoveredTile and the ShowAnalyzedTile. I named the function SetShowTileStates, and once the two booleans are set, we can call it the UpdateStateOnAllTile function, like that. And now the last thing we need to do for this blueprint is to call the toUpdates function. So this is in the event graph right here. We are using the callback and this event right here. So we're going to use them both. So the first one is the UpdateStateOnAllTiles that I'm just going to drag right here and connect it at the end like that. And then what I'm going to do is just funnel my two callbacks inside that event right here. So I'm just going to change this callback right here so it fits with that event. But here, since our event has an input and it doesn't correspond to the signature of the callback, we can't select it in the dropdown right here. So that's not good. We need to create a second event so we can bind the second callback. So let's create a second event right here. I renamed it event re-update all text and colors after delay underscore no input. The name doesn't really matter, but we need a name, so that's the name. And I've also renamed the other one, so it's renamed all text and colors after delay. So I included the colors inside the name of the first event. And now if we compile the blueprint, we should now be able to go in the create event and select the new event we created. So event re-update all text and color after delay underscore no input, that one. Good, we can now go attach those two booleans inside the tab. So I'm gonna go in entry, I'm gonna go debug menu, tabs, and open tab Pathfinding right here. And here I added two new checkboxes, so show discovered tiles and show analyze the tiles. Then we can implement all the events, so select the checkbox, go implement the event, and the same thing for the other checkbox, so select it all the way down, implement the event. Then we can connect both events to the SetShowTileStates. And finally feed the check state of both checkboxes inside the function. And I think that's it, so we can compile, save everything, and go test it. I mean that my grid is as big as my environment. Now I'm gonna go in my pathfinding, check the two new checkboxes that we just created, select my select and find path action, and now if I select an action and try to generate a path, we can now see a few more tiles, the pink tiles, which are the discovered tiles, and the dark pink tiles, which are the analyzed tiles. Oh, that one was big. But yeah, so you can see here we have a few analyzed tiles over there, and right here we have a few extra analyzed tiles over here. So we can more understand how the pathfinding works. Perfect, everything seemed to work. And if we only decide to show one of them, it hides the other, so that's pretty good. It works as expected. Perfect. We can now stop that. Okay, it's now time to slow down the pathfinding, so I'm gonna go in grid and open BP grid pathfinding. And here I'm going to create a new variable to keep track of the delay that we want to use between iteration of the pathfinding. The variable type is a float, and I named it delay between iterations. Then we need to set it inside the FindPath function at the beginning where we are setting all the variables, so let's set it right here. And that's how I connected it, so I just placed the set after all the other ones and I created a new input which is a float and I named it the delay. And now this is where things get a little bit complicated. If we want to use the delay, we can't use it in a function. And right here at the end, we won't be able to return at the end of the function because we're not gonna be inside the function anymore, we're gonna be outside of it. So we're gonna need another way to return the path to the place where this function was called. So somewhere called this function and is expecting to receive the path, but we can't return it like that because we're not gonna be inside this function anymore. So instead, we're gonna use a callback, another callback. So let's create it, create a new event dispatcher. So here it is, I named it onPathfinding completed, and it is returning a path which is an array of endpoint, the same way that the function was doing before. And now, since I want both systems to be compatible and work at the same time so we are able to either decide if we want to use a delay or not, I'm going to call this callback everywhere in the function we are returning. So here I'm going to call it, and here I'm going to call it. So take the callback, call it here. Take the callback, call it here, just before returning. And that's how it looks once it's connected. So right here at the top, after the generate path, I'm passing it the path and then I'm returning the same path. And at the bottom, I'm doing the same thing. So I'm returning the make array in the callback and then I'm returning it at the end of the function. Unreal gives us a note for both these callbacks, but it doesn't matter in that case, so we can simply ignore it. And if I remember correctly, we still have a few places, or actually just one place right here where we are returning. So we're going to do the exact same thing. So call our callback right here. Just like that. Perfect. And now, as I said, if we want to be able to use this delay, we can't do it inside this function. So we're gonna need a new event in the event graph because that's the only place where we can set delays. So I'm going to create a new event right here. So custom event. And I simply named it FindPathWithDelay. And now we have to go back in the FindPath function to call this new event. So FindPath, and I'm going to call it right here instead of calling the loop. So if we want to use a delay, we're not going to use the while loop. We're going to loop ourselves in the event graph instead. But if we don't want to use a delay, well, we are simply going to execute the rest of the code the same way we did like that. And that's how I did it. So before the while loop, we are doing a branch. We are checking if the delay between iteration is smaller or equal than 0. So if it is 0 or less, we are just going to use the simple path that we were using before. Otherwise, we are going to call the new event we just created. But here we also need to return because it's going to be the end of the function. So let's do that. I'm going to copy paste those two nodes right here and return like that. I'm not going to call the callback because it is going to be called at the end of the event in the event graph. So we are simply going to return an empty path for now, and later on the callback will be called with a potential path. And that's it for this function. So now we have to go do the logic of the event, which is going to be pretty similar to what we have right here. So I'm just going to copy all that, go back in the event graph. I'm gonna focus on this event right here, and I'm going to paste all my nodes right there. And here the first thing we have to do is to replace the while loop, because the while loop is going to continuously execute itself over and over and over until the pathfinding is done. But right now that's not what we want. We want to be able to have a delay between iteration of the loop. So we're gonna replace the while loop by a branch like that. So let's just connect the branch instead of the while loop, and then we can delete the while loop, just like that. And we can also connect it to the beginning of the event, like that. And that's how it should look. So okay, we're now ready to add the delay in there. Here I added a new retriggerable delay. It's not connected to anything right now, but it is right here, and I'm using the delay variable to set the duration of the retriggerable delay. And it's now time to connect that little guy, and it's going to be a little bit messy. The first thing is the completed, so let's connect it like that. And then for the input, we have to connect it back to the false right here. So let's add some reroute node just so it's cleaner, just like that maybe. And actually that's it. We can now test and see if it works, but first we have to go set the delay in the find the path action, and we also need it to use the callback instead of using the return of the function. So let's go do that. I'm gonna go back in entry, go in my actions, go in pathfinding, and open the find path to target action. Now we're gonna go inside the execute action and create the delay variable that we need. So right click on it, promote to variable. And I named it delay between iterations, and we can simply pass it to the function just like that. And now for the callback, we actually need to do something first. We need to create a new function for all that logic right here. So the logic that displays the path to the user, we're going to move it inside another function that will then be called by the callback. So to do that, I'm just going to right click on those nodes and collapse them to a function. I named the function onPathFinding completed, and I've also renamed the input so it's written path. And now, since this function is going to be called by the callback, we're not gonna need it right here. So let's delete that. And now the last step is to bind ourselves to the callback. So that's what we're doing right here. We're getting the pathfinding, we're binding the new function to it. So we're doing a bind event to onPathfinding completed, which is the callback inside the pathfinding. And then we're connecting that to a create event, which points to the onPathfinding completed function that we just created right here. So now when the callback is going to be called, it's going to also call this function right here. And now we just have to include that inside the flow, and we're actually going to place it right in between right here, just before calling the findPath function. That way, if the findPath completes immediately, it's going to work. Otherwise it won't if we connect it after. So just like that. And now just to see if it works, I'm just going to add a default value in the delay between iterations. So let's say 0.5 seconds. And now we can compile and go try that. I'm gonna play, go in my pathfinding, select and find path, select a tile and right click. Okay, nothing happens. That's a bit weird. But what if, oh, okay, the path happened. Okay, so it took a bit of time. Okay, what if we check the discovered and the analyzed tile now? I'm just going to do another path, and here we go. We can see that the path goes every 0.5 seconds, and it takes a bit of time to generate, but it looks cool. At least we can see how it goes. Perfect. So we can stop and go add this value inside the slider, so we can change it dynamically. So stop for now. And I'm actually going to start by going back in the action and just resetting the delay. So I'm gonna set it back to 0, and now we can compile and go inside the action widget. So it is in the widget action find path to target. In the designer, I'm gonna start by adding a new spin box with name in the widget, so right here. And here what I just did is renaming my spin box so it has the right name. Then I changed the name written on the text, so it's written delay. Min-max value is going to be 0 and 1 because more than 1 second delay, it's a bit long, I guess. The min-max slider, I set it to 0 and 0.5 because it's rare that we're gonna want to go higher than 0.5. The default value is gonna be 0. The min-max digit are gonna be 2 and 2 because we want to have 2 digits after the dot. And then not always snap to delta, so it's unchecked, and the delta is gonna be 0.01. And then we can go in the graph. And here with the spin box selected, I can implement the event on value change, and I'm going to connect it with the other one, like that. And now we can go set the value right here. And I did it like that, so from the find path to target, I'm setting the delay between iterations, and I'm using the value of the spin box like that. And now we can go see if it works, so I'm gonna play again. And now if I try to draw a path, I'm gonna do that. Okay, if the delay is 0, it's instantly, so that's good. It's super fast, great. And now if I add a little bit of delay, just like that, let's say. Okay, okay, it's slower, but we can still see the progress, good. And now if we put it even slower, okay, it's back to what it was when we were setting it to 0.5. It's going super slow, and we can see everything one by one. Perfect, so it works as expected, good. We can now stop. And actually, I just spotted two little bugs. The first one here is the delay. You can see that it is still visible even though my action is not selected. So we're gonna hide it when the action is not selected. So we're gonna start with that one because it's pretty simple to fix. And it is inside the button. So right here, we are setting the visibility of the checkbox. So we're gonna do the same thing for the spin box. So I can just copy paste the spin box and pass it at the same time as the checkbox, like that. So it's gonna apply it to both of them at the same time. And now if I go back in the pathfinding, we can see that the delay also disappears when the action is not selected. Perfect. And the second bug is a little bit more complex. So here I have a grid and I'm in the pathfinding tab. I'm gonna try to draw a path. So I'm gonna make it 0.5 seconds so we can see progressing. So I'm gonna start in the bottom left corner and go all the way in the top. So we can see the path started and it works. I can see my FPS right here, it's 70 FPS, it's pretty semi-stable, it goes down when it generates new tiles, but it's pretty stable, so that's not too bad. But now if I bring my delay all the way back to 0, and I right-click to generate a new path right away, before the other one was done, you can see now that there's a problem. My FPS is 6, that's bad, and also I'm drawing all the tiles and I'm calculating all of them, even though my path is already generated. So the pathfinding should have stopped, but it didn't, and now it's trying to generate a new way to access that tile, I guess. I don't know. Yeah, but it won't be able to because we already analyzed the tile, so it can't find it anymore. So now it's stuck in a loop forever. And if we go in the grid pathfinding right here, we can see the loop. That's the loop. That's the loop that it's stuck in, and it's going over and over and over and over every frame, because right now the delay is still 0, so it goes over and over super fast, and that's not good. So we're gonna have to fix that. And the reason why it happened is because this loop right here never had time to finish before we started a new pathfinding. And since the second pathfinding we started was with a delay of 0 seconds, it never entered this part of the code anymore. Like, it went directly in the find path right there. It went directly to the end right here. So it executed that code instead of this one, which means that this loop was completely broken and was still working. And we're going to do that with a gate. I know the code changed a little bit because I offsetted all that, but I just added a gate right here. So we're gonna do that. That way we are giving us a way to just block the flow whenever we want. But before closing the gate, we have to first open it, and that's what I'm doing by adding a sequence at the beginning of the event with the first spin right here connected to the open gate. It's opening the gate, so we are calling this event, it opens the gate, and then the flow continues. And then once the gate is not closed, it's going to go all the way back here, wait for the delay, enter the gate again, exit again, and execute the flow over and over and over. But now we can close this gate whenever we want to stop it, which we're gonna do with a new custom event. So I created myself a new custom event and I named it close delay gate. And now we can go call this event inside the findPath function. So right here, and I'm going to do it at the beginning. So right after setting all the variable, I'm going to call the event right there. So close delay gate, call it right here like so. And that should fix the problem. And now let's see how it goes. I'm going to select the first tile and the other tile. Okay, the pathfinding works one by one, that's good. Now I'm going to reduce the delay to 0 and click again. Here we go. So now my FPS is back to normal. If I go back in my grid pathfinding, I'm gonna go back in the event graph here. We can see that the flow is not executed over and over and over until the end of time, so that's good, and my path is generated, so that's great. Perfect! The bug is fixed. And since we're talking about optimization, I'm just going to show you a little something else. If I try to generate a new path right now, we can see that my FPS drops every step of the path, so it goes to every iteration of the pathfinding, and we can see here what causes the problem, and it is in the debug text and color on tile, and it is when it updates the states on all the tiles. But right now I'm not showing any states, so I'm not expecting to see any states on the tile. So this code should not be executed if we don't want to show any states. Same thing for the text. So we're just going to fix that real quick. And the problem is right here, so the update state on all tiles, because the callback is called, which is calling this event, which then is calling that function. So good, okay, let's go in there. If we are not showing any of the discovered or analyzed tiles, we are simply clearing the tile. Okay, that should be fast. I don't know why it takes so much time. Okay, let's open that function, we'll see. And here what we do, well, we get the tile with the state. So the first iteration, yeah, sure, we might have some tiles with that state and then we have to clear them. So that's good, that makes sense. But then the second iteration should be pretty fast because we already cleared it. So it should be empty, we don't have anything to clear. So that should be pretty quick. I don't know what's happening. So I'm gonna go inside the GetAllTilesWithState because I think that's where the problem is. Okay, yeah, that's the problem. Right now what it does, it's getting all the tiles in the grid, all of them, and then comparing all of them one by one to check if they have the state. And this is bad, like it's really bad. It works for a small grid, but on a bigger grid, that's a pain. Okay, scratch that, scratch what I said with not calling that function. Instead, we're just going to fix the function because that one is going to cause us more issues in the future. So we're just gonna fix that. So first thing, I'm going to delete all that because we're clearly not going to loop through the grid. That's just a stupid idea, I think. So let's not do that. Instead, I'm going to delete the return also because we're not going to need it, and we're just going to connect it like that because we're going to create a new variable to keep track of all the indexes for every state. So that way we can simply get the state, okay, get all the indexes from that state, which is going to be a find on a map. It's going to be pretty simple, and then we can just return all the indexes right here. Okay, so let's create the new variable we need. I named it TileState2Indexes, and it is a map. The first type of the map is the tile state, and the second type is an int point, because we want to map from a tile state to an int point right here. And now we can simply do a find on the map to have access to the int point that we need. Oh wait, that's a problem. This needs to return an array of int points, not only one int point that we have right there. So we need to have a way to add an array of int point inside a map, which is not possible by default in Unreal. It is not possible to add an array inside a map by default. So we have to create ourselves a structure just to be able to do that. So that's what we're going to do. So let's go do that. I'm going to go in entry, I'm going to go in my grid, in utilities, and I'm going to create a new structure right here. So blueprint, structure. I named it s_int_point_array because it's simply going to be an array of int point, and now we can open it. And here I just renamed the variable int point array and I made it an array of int point. That's easy. Okay, let's close this structure and go back in the grid. And now in my variable, I'm going to change the second element. So instead of an int point, it's going to be the int point array we just created. So s_int_point_array. Yes, we are going to change the variable type. We can close this, it doesn't matter. We can reconnect the find like so. Now we can't connect it just like that, but instead we can simply right click on it and split just to have access to the array inside the structure, and now we can return it like so. Here we go, that's way faster than looping through all the grid just to find the indexes. But now for it to work, we have to add the tiles inside the variable because right now we're not doing that, so it doesn't work. So we're gonna have to add them in there. So let's do that. I'm gonna go in add state to tile first, and I'm actually going to go right here at the end. So right after the add inside the grid data, I'm going to add it inside the new variable also. But I'm just going to make myself a little bit more space because it's going to be a little bit more complex than just adding it like that. So we're gonna do it like that right here. So the first step is to get all the indexes with that state, the state that we receive as input at the beginning of the function. So we receive a state, we start by getting all the tile from that state, and then we add the new index to it. So we are getting the indexes, we're adding the new index. And now that this output right here has the new index in it, we can simply pass it inside our variable. So we are getting the tile state 2 indexes, we are doing an add on it, still keeping the state, the same state that we are using right here. And then we are making a nest point array using the array that we receive right there. So we're getting all the tile with the states, we're adding the new state in them, and then we are setting the variable. Now we're going to do the same thing for the remove, so I'm just going to copy all that and I'm going to go in the remove state from tile function. Right there after the add, we're going to paste it right here. So that's how it looks once it's reconnected, but here I don't want to use the add anymore, I want to use a remove instead, so I'm just going to remove that one. I'm going to add a remove node, connect my array and my index to the remove node, and then we can connect it back to the add like so. So we are getting all the indexes, we are removing that specific index from the list, and then we are setting the list back inside the map. And here we go, just that should have speed up the code a little bit, so let's go try that. So here I recreated the same exact scenario, so I'm selecting my action, and then I can select a tile, and I can start a path from the bottom left corner all the way to the top right corner. And you can see that it doesn't cost anything, it doesn't cost much. Now if I show my discovered and my analyze, just to make sure that it works, now it's expensive, a little bit more expensive because it's generating the grid and the tile states. But other than that, if we hide them, here we go, it doesn't generate everything, so that's good, now it doesn't cost much. Good. And since we fixed the code at the root of the problem, it means that everywhere else that we're going to use that feature, it's going to be more performant. Perfect. And now it's time for the last thing I want to do today, and it is to be able to generate super long pathfinding without freezing the game. Because right now, if you look at it, I don't know if you see the FPS in the top right corner right here, but it freezes. It freezes for like half a second, I think, when I click. Maybe not half a second, but still, it freezes and it's super annoying, and it actually freezes the whole game. So all the animations, all the particle effects and everything is frozen during that time, and that's not good. That's not what we want. We want to be able to have the possibility to generate a smooth path without freezing the whole game every time. Right now it's possible to do that by adding a small delay, so let's say 0.01, so I have a super small delay, so when I click now, I don't freeze the game and the pathfinding is calculating. Okay, it takes a bit of time though, it takes way too much time, my FPS is still at 70, 80, it could go a little bit faster, but for now that's the only option I have, so I can deal with it, but that's not perfect, it takes way too much time and my computer is better than that. So that's why instead of having a static delay of 0.01 seconds or whatever the numbers you write, I think it will be nice to have it depending on the performances of the computer. So if the computer is super fast and it takes no time for him to generate all that path, maybe he can do it on 1 frame, or maybe it just needs 2 frames, 3 frames, maybe 10 frames, or maybe if you're like on a cell phone or something, it takes like 1 minute. Something like that. I'm exaggerating, but I mean, that's the idea. It is that if the computer is faster, we're gonna generate the path faster, and if it is slower, we're gonna generate it slower, but without freezing the game. That's the objective. So let's go do that. I'm gonna go in my BP grid pathfinding to do that. And here, first thing I'm gonna do is create a new variable. I named it max ms per frame, and it is a float. And we're going to use it to limit how much milliseconds the pathfinding is going to use per frame. That way, when the pathfinding reaches that limit, it's going to stop and wait for the next frame, and then continue. And we are going to insert it right here in the flow. So in the false, so when the analyze is completed before retriggering the delay right here, we are going to first check if we exceeded the limit of millisecond allowed to use. If we didn't, well, we're going to skip the retriggerable delay and simply go to the next loop. So here you go. Here I'm checking if we have a limit of milliseconds, because if we don't have a limit, well, we assume that we always want to retrigger the delay every iteration, the same way we did right now. But if we have a limit, well, we're gonna check and make sure that the limit is not exceeded. Okay, good. We now have a limit and we want to use it to determine if we exceeded it or not. But how do we do that? Well, we're gonna need to know when the loop started, and then we're gonna compare to check, okay, how much time was passed since the beginning of the loop. And to do that, we're gonna use a function named now. So now, this one right here, which returns us the time, so that's good, that's exactly what we want. We can just promote it into a variable to keep it in mind for later. I named the variable loop start time because it is the time at the beginning of the loop, and we're gonna connect it at the beginning of the loop. So right here after the gate and before the branch, just like that. And that's how we're gonna check if we still have some time left before reaching the maximum limit of milliseconds we have before having to wait at least one frame before starting a new loop. So here, if it's true, it means that we still have some time left and we can go directly to the next loop. Otherwise, it's going to be false, and it means that we're gonna have to wait at least one frame before going to the next one. But how are we going to decide that? Well, we're doing it right here. So we're getting the now again just to see the difference of time that happened since the beginning of the loop and the current element in the loop. Because even if it's going super fast and it doesn't take that much time, the time still continues to go forward, because that's just how it works. The time just goes forward. So we're just getting it again, and we're making the difference between the now and the now that we set at the beginning of the loop. So the variable that we have right here, we are checking the difference between the current now and that variable. And then we can convert it to milliseconds because our variable is in milliseconds. So to be able to compare them both together, we have to convert it to milliseconds. And then we can simply check if it is smaller than the maximum milliseconds allowed. If it is smaller, it means that we have more time left, and if it's not, well, we have to wait. And now we just have to connect the branch. So if it's false, it means that we have to wait a little bit before the next loop. So we're just going to go right here, go back to the retriggerable delay, which is going to wait a little bit and then start a new loop. And if it's true, it means that we can directly go to the next loop, which starts right here at the branch, because we're gonna skip the set of the variable, otherwise the calcul right here won't work. So we have to skip this and go directly to the next loop with the branch. So I'm just going to connect the true all the way back here. And then we can add some reroute nodes just to make it a little bit cleaner like that. Perfect, that should be good to go, but now we're just gonna add another slider in the user interface to be able to change the maximum milliseconds. But first I'm gonna go in FindPath just to set the variable at the beginning, the same way we did for the delay between iterations. So we can connect it like that at the beginning and create a new input in the function. And that's how it looks. So I just renamed the variable maxms instead of maxms per frame because it was too long. And now for the slider, I'm gonna go back in the button, go in the designer, duplicate the slider. As usual, I renamed the checkbox, I changed the text, I changed the min-max so it's 0 and 30. 30 because it's pretty much the maximum amount of millisecond you can have in the 30 FPS game. And then the max slider, I'm stopping it at 20, so between 0 and 20. And then for the value, it's 0, min-max digit, 0, 0, not always snap, and then the delta is 0.01. And then we can go in the graph. And here, same thing we did with the previous spin box. So we can select the spin box, implement the event, connect it like the other ones right here, and then go all the way back here just to set the variable. And actually, our variable doesn't exist in the action quite yet, so we're gonna go create it real quick. I have my action right here, so I have my FindPath function over here, and now I can right click on the input, promote to variable, which I named max ms per frame. Okay, we can go back to the button. And we can now set the variable max ms per frame using the new spin box we just created. And finally, we have to set the visibility, so I'm just going to copy paste that spin box right here, right there, and connect it like that. And that's it, we can now compile, save, and go try all that. Okay, so here I recreated my big grid and I added a bunch of obstacles here and there just so the pathfinding take a little bit more time to execute, and I'm gonna start by trying to see how it looks without delay or max milliseconds. So I'm gonna select the bottom left corner and then all the way up to the top right corner. Okay, I don't know if you saw it, but yeah, the game freezes for, I'd say at least a second. So okay, yeah, it freezes for at least 1 second, so that's not great, and during that time, everything else is frozen in the game, so that's not good. So now I changed the delay so it is 0.01 seconds, and the max millisecond is 10 milliseconds. And now let's see how it looks. If I click here, it takes a bit more time to generate the path, but if you look at the FPS, I'm always above 50 FPS all the time. So 50 FPS during the whole duration of the path. So that means that the player can move, the player can decide other actions, or maybe decide to cast a spell or something like that, and everything still works as expected. Okay, but what if we boost it all the way up to 20 milliseconds? Now the FPS is going to be lower, it's going to be 30 instead of 50, but the pathfinding is generated way faster. So that's where you can use this variable to decide how much performances you want to allow to the pathfinding, depending how much the rest of the game is expensive. Because if you have a more expensive game, you're gonna allow less performances to the pathfinding and vice versa. So yeah, that was technically everything I had for you today, but I just found a little bug that is a little bit annoying. If we enable the discover tile and the analyze tile on a super big grid like that, and now if I try to generate a path, we can see that my FPS drops all the way to 1 or 2 FPS. That's so slow, and it is because it's refreshing everything on the grid, even though it only needs to refresh these tiles right here. So I'm just going to change that logic a little bit so it doesn't freeze the whole game when we are displaying the debug info. And to fix this, I'm gonna go in BP, debug text and colors on tiles. And the problem comes from here. So what the system does right now is every time we are updating a tile in the pathfinding, this is going to be called and then it's going to wait a little bit just to make sure that everything that needs to be updated was updated during that call. And once that's done, we're gonna update everything on the grid at the same time. So if there's a ton of tiles on the grid, it's going to take a lot of time for no reason really. So we're not gonna do that. I'm just going to delete all that. We might end up having some issues with the data written on the tiles for the sorted cost, but do we really care about that? Not really, it's just debug info, so if we need to refresh it for some reason, we can just simply refresh it by unchecking the checkbox or rechecking it again, or maybe passing the mouse over the tiles. So now if we compile, we're going to have a few errors right here in the binding, so let's fix that. For the on-pathfinding data cleared, it's easy. We're simply going to call the UpdateStateOnAllTiles. And for the pathfinding data updated, we're going to call the UpdateStateOnTile function. So now if we compile, it shouldn't complain anymore. Perfect. But now we're not updating the text anymore, we're only updating the states. So what I'm going to do is just duplicate all that. I'm going to paste it right here. Connect it like so, and then I'm going to replace the event for update text on tile instead of update state on tile, and I'm going to do the same thing here, so update text on all tiles instead of update states on all tiles. So now we are updating the state, and then we are also updating the text. Perfect. And it's now time for the last change we have to do. While debugging this feature, I found another little problem, so we're gonna go fix it, and it is in the BP grid pathfinding. Inside the analyze next discovered tile function, right after we are pulling the tile from the discovered list, we have to call the onPathfinding data updated because the tile was pulled out of the discovered list and is now in the analyzed list, so we have to notify the debug menu if we want to update the color. So we're just connected like that, and I'm going to break the structure just to have access to the index and connect it like so. And that's it, we can now compile, save everything and go see if it works. And here we go, we're now back with the grid with a bunch of holes in it, so I'm gonna try to find a path from the bottom left corner all the way to the top right corner and see how it looks. Okay, we can see the algorithm works and that's pretty nice. Okay, it found its paths all the way to the end, so let's try with this one right here. Is it going to work? It takes a little bit of time. Oh, it goes down. Oh, okay. Is it going to find a way? I don't know if it's possible. Yeah, it is. Good. And if I go here in the bottom left right corner instead, takes a bit of time to clear all the states at the beginning, but once it started, it seems to work perfectly and it doesn't lag too much, so that's great. And obviously it takes time at the beginning because it clears the state, but if we are not in the debug state, if we are just in the normal state, we can just generate a path and here we go. I don't freeze and everything's fine. So that's just perfect. Great. So that's gonna be it for today. I'm gonna see you in the next one. Bye bye.